Can you please introduce yourself and explain your career to this point, how you got to specialise in urban heat issues, among other things?
I currently am the professor for urban management and planning here at Western Sydney Uni and look into urban heat and urban cooling. And all of that really came about through the development in 2016, 17, 18, where we saw a lot of heat waves. There was extreme drought, we had bushfires, and people working in this urban space started to recognize that there is a real problem if these extreme conditions persist and even become worse. We had the first models telling us that heat waves for Western Sydney will become more frequent and more extreme. And so something needed to be done. And of course, you want to underpin that with research. And so that's where I started to establish the research that we're doing today.
Can you explain what urban heat is and what impacts it has on suburbs in Western Sydney like Penrith?
Mm. Penrith is a very good case study. We always call it like a playground where we can establish conditions and therefore also solutions for the future that other countries may experience in 20 years because it's so extreme already. Now, urban heat is basically a composition of a few things. So you have the underlying effects of climate change, and that means global warming. We know that our temperatures here in Australia have now warmed compared to pre-industrial times by about 1.5 degrees. So we have reached Paris in 2023. We already went over the 1.5 with our annual average temperature being warmer than in pre-industrial times. So we are reaching those Paris targets already, which means that gives us like a baseline warming that we need to deal with. Because of that, we also see that extreme heat conditions are now occurring more often, are longer lasting, and their maximum amplitude is also going up. I measured 52 degrees Celsius in Penrith when we did the heat study for Penrith. So these are realities that the communities of that part of Western Sydney now face. Yes, we had over the past 3 years slightly milder climate, but overall we're still tracking elevated temperatures. And in Penrith and in the lands around Penrith, particularly to the north, but now with the airport also to the south, we do see on top of what we call the baseline warming through climate change, also additional warming from the transition of pastures and horse country into new suburbs and into an airport. That process replaces pervious green surfaces with gray impervious hard surfaces. And that means you change how much moisture is in a system and also how energy is stored and then re-emitted. And that's the problem where we see particularly those so-called urban heat island effects to unfold, where you have during the daytime a lot of heating of the hard infrastructure, and because of its thermal mass, which is high compared to pasture and grass and so on, it means it stores the heat very well and releases that during the night. That warms the air and that gives you the urban heat island effect. And so we see very pronounced urban heat island effects on top of the climate warming in the area. St. Mary's is one of the hotspots, but then also going through the city towards Emu Plains. These are all lighting up from our measurements as urban heat islands. And in combination with climate change, we talk about urban overheating. And that is exactly what we're finding out west. To me, there's nothing mythical about urban heat. It is something that we measure regularly. As I said, 52 degrees, there's definitely nothing mythical in that. There is, to me, an issue around recognizing how much we actually can do. Like, where are our limits where we can influence what we call urban heat and urban overheating, and where we just have to adapt. So there is this discussion around mitigation and adaptation. Mitigation would have been good 20 or 30 years ago. Adaptation is what we need to do now, because a lot of things where we thought we can mitigate extreme heat, we don't have the means anymore. It's too extreme. When we get to 40, 42 degrees Celsius as maximum air temperature during the day, there's very little we can do about that, because these are many cubic kilometers of heated air coming from inland Australia into Western Sydney. A few trees that we plant, and even if we plant 1 million trees, they will not cut it. So we have to keep the community safe, we have to start and adapt much better. And that also means we have to rethink how we build our new suburbs. That's one of the large projects that we're working on now for many years, looking into the materials that are used, the colors, the reflectivity. Do we need double glazing as a standard? And do we need to ban dark roofs? So all of these things would then have an impact on urban heat, but we still need to keep people safe. And so when we get to 40, 45 degrees, even 50 degrees, we need to have means to keep them safe. With Penrith, we did the study in what we called the angry summer. So that was the summer of 2019, 2020, when the Blue Mountains were on fire. We had extreme heat wave temperatures, and that was ended basically by floods in 2020 when the rain started. And of course, after that, we were hit by COVID. So it was just an absolute crazy time. We were lucky enough to have more than 100, I think it was about 120 temperature sensors that we distributed all across the local government area. And this is work that nobody else is doing anywhere, to my understanding, even worldwide, using many temperature sensors that log air temperature at a 10-minute frequency. And then because we do this over the whole local government area, we're amassing millions of data points over summer, and then bring this data back and start to analyze it. And so what we do is, as I mentioned before, we're not modeling anything, but we're creating maps that are based on empirical measurements. So we can, for example, visualize summer nighttime air temperatures. So the average air temperature across the local government area between 9 o'clock in the evening and 5 o'clock in the morning. Where is it hot? Because that's where the urban heat island effect is. And for example, with Penrith, we found when we used what is called the heat vulnerability index. This is an index that the state government provided. We use the heat vulnerability index and we compare that with our hot nights, and you can see that they're absolutely matching. So those people that are highly vulnerable to heat, and that is based on socioeconomics, education, age, and so on. So it's a combined level of looking into the risk of how well are you prepared, how well can you adapt, and how well can you recover from extreme heat. And we match that with our extreme nighttime temperatures, where we only looked at nights that were related to heat waves, where air temperatures were above 30 degrees. So really hot and uncomfortable nights. And we know that they have health impacts because the admissions to the emergency room, the ER, go up when you have these hot nights. People can't cope. They don't recover from the daytime heat. And we found that with parts of the Penrith LGA, particularly the area around St. Mary's, and then also a little bit further west, matched perfectly with those heat vulnerability indices being very high. And that, of course, means these are areas where now council knows, not only from statistical data, but also from empirical heat data, that they really need to focus on helping these communities to get through these extreme heat events. And so it was just a perfect match to showcase how measurements of air temperature can inform policy down the track and development down the track delivered through council. And that's exactly what they did. They amended their local environment plan, the LEP, which now has clauses in it for mitigating heat during development. So it's exactly that kind of translation from measurement through science to communicate and then amend policy so we get better outcomes in the long run. That's a master plan community. So it went through this state priority process. Therefore, Penrith didn't have a lot to say about Jordan Springs. Lend-Lease wanted to be a forerunner in sustainable development, and they did a few good things, but they also admitted that there were quite a few things that weren't so good. So if you just look at the black roofs, if you drive up from Penrith towards Richmond, you drive past Jordan Springs and you just look to the right and everything is just black. Very little canopy. The same problem, big houses, small lots, lots of road surface, very little tree canopy. So really a problem that could have been addressed much better. What they did really well was, for example, putting 2 lakes into this area. We know when you have water surfaces, they help cooling during the day because of evaporation from the surface. That influences what we call the latent flux of heat, and that produces cooler air, and that air with wind is distributed into the suburbs. So that was a good thing. What they also did really well, and this is something that we advocate should be done everywhere where you have greenfield development, they took the existing canopy, at least in the places where they wanted to establish the new parks, and then designed the parks around the existing tree canopy. So what the effect was that these came up, when we did our measurements for them, these came up as the cool islands because you already had established tree canopy, and therefore you had the coolest air possible in those parks that had the existing tree canopy incorporated. So that was a really smart move. There were interesting concepts that were trailed. It would have been great if they mass produced them. And I hope that for Ländli, such a big developer who has written into their, commercial applications that they are extremely sustainable in what they're doing, they should expand these kind of projects and really implement what they can, and they showcase they can, into other settlements that they're developing throughout Western Sydney.